Welcome, everybody. If you weren't here last week, I am Andy, and I have been in and around construction since high school. I have built and remodeled homes, then I got into actual residential construction, and then I went into commercial construction, and now I'm here. So lots and lots of construction experience, and hopefully you will notice that as we go through this webinar. So here we go, get started. So how to perform deck inspections. Um, there we go. All right. More than 2 million decks are built and replaced each year in North America. InterNACHI estimates that of the 45 million existing decks, only 40% are completely safe. Because decks appear to be simple to build, many people do not realize that decks are, in fact, structures that need to be designed to adequately resist certain stresses. Like any other house or building, a deck must be designed to support the weight of people, snow loads, and objects. A deck must be able to resist lateral and uplift loads that can act on the deck as a result of wind or seismic activity. Deck stairs must be safe and handrails graspable, and deck rails should be safe for children by having proper infill spacing. Rail failure occurs much more frequently than total deck collapses. However, because rail failures are less dramatic than total collapses and normally don't result in death, injuries from rail failures are rarely reported. Home inspection standards of practice. So this is the InterNACHI standards of practice. I did review the New York standards of practice, and it is almost identical. There's things are kind of mixed around, and but for the most part, everything complies. The InterNACHI standard complies with the New York State standards of practice. And then if you're not in New York, just definitely refer to your SOP as is required by your state. And just go and see how, and it's good knowledge to have, but what is the difference between the InterNACHI standard and your state standard? I think those are important differences to note, especially as you attend nationwide webinars like this. So the inspector shall inspect the exterior wall coverings, eaves, soffits, fascias, representative number of windows, all exterior doors, flashing and trim, adjacent walkways and driveways, stairs, steps, stoops, stairways and ramps, porches, patios and decks, balconies and carports, railings, guards and handrails, and the vegetation, surface drainage, retaining walls, and grading of the property where they may adversely affect the structure due to moisture intrusion. So decks and similar structures. So the definition of these pictures here is a deck is a large raised wooden floor attached to the back of a house and contained by a perimeter railing for safety. Decks are rarely covered and usually have a rough or informal look that is not integrated with the rest of the house's design. They are typically intended to be locations for large outdoor social gatherings, such as barbecues and birthday parties. Access to the deck may be from the ground through a stairway or from the house through a back door or both. A porch is a wooden structure that forms a covered entrance to a doorway at ground level. A porch is typically located at the front of the house. A veranda, and you know what, let me get my identifiers here. All right, so here's your veranda on the right-hand side. A veranda is a long roofed open gallery built around a central structure and supported by pillars. Verandas are often long enough to extend around the front and the sides of the structure. Their origins are uncertain, but they are known to be a hybrid of Indian and European styles. The purpose of a veranda is social, although in a more relaxing everyday sense than is the case for a deck or patio. A balcony is a platform that protrudes from the wall of an upper floor of a building and is enclosed by a railing. Balconies, which here, right? Balconies are often highly decorative, especially in wealthy and scenic areas. They are not designed as social areas, but rather as an outdoor ambiance to the indoors. And a patio is typically, which right here, patio is typically a paved, roofless surface adjoining a residence that is generally intended for dining and recreation. These open air Open air living spaces are at ground level and are usually made from cement, stone, slate, or a combination of these materials. And let me get rid of that. All right. So deck load. A deck inspection should progress in much the same order as deck construction. Inspectors should start at the bottom. If a deck is deemed unsafe from underneath, the inspector should not walk out onto the deck to inspect the decking, handrails, and etc. The inspector should stop and report the safety issues. The IRC provides design tables for decks up to 10 pounds per square foot, dead load, and 40 pounds per square foot live load. Most decks are designed and built for loads of 40 to 60 pounds per square foot. The 2021 IRC includes snow loads of 50, 60, and 70 PSF. Just refer, if you're concerned about that, refer to the 2021 IRC 301.2. A 40 PSF live load is equivalent to a 200-pound person standing in every 2.5 foot by 2 foot area on the deck. That's a lot of people standing near each other on the deck. Stairways also must support this load, but in addition, must support a concentrated load. Hot tubs are common on decks, but they provide a significant concentrated dead load. Hot tubs filled with water and people are heavy and can weigh a couple of tons. Hot tubs require framing that can support more than 100 pounds per square foot. Engineered or alternative designs for supporting a hot tub may be necessary, but may be handled with an over-design in the joist and beam sizing, spacing, and spans. Move my window here. Building codes require decks to be designed to carry a uniformly distributed load over the entire deck. But even if distributed, half of the load on an attached deck can be carried by the deck to house connection and the other half can be carried by the post. But in reality, the live load is usually near the outer railing edge of the deck and balcony. That's where people tend to gather, so more load is likely carried by the posts. Footings and posts. So deck footings are sometimes not visible during a home inspection, especially if you have a deep frost line. Which is, I believe, the case in New York and in all the northern states, pretty much. And I did look up. Let's see here. I looked up some of your depth requirements for getting below the frost line, and from what I could find, and this is just a quick search, so this may or may not be right, but we're looking at 42 to 48 inches of depth to get below the frost line in New York City. If anybody has any other information on that, please post that in the chat. But that's just a quick search is what I can find. Let me get back to all right. So deck footings, let's see. Yeah, deck footings should be sized on average 3 times the size of the support post. You can refer to the 2021 IRC 507.3 for those sizes. Footings are not required for freestanding decks with joists directly supported on the ground over the entire length of the joist. Here's some more. 42 inches in southern New York. All right, thank you, Jeff. So footings are not required for a freestanding deck that meets these requirements. The joists bearing directly on precast concrete pier blocks at grade without support by beams or posts. A deck not larger than 200 square feet, or a walking surface is not more than 20 inches above grade at any point within 36 inches measured horizontally from the edge. The settlement of soil located below a deck can pull the deck away from the ledger attached to the house, as is, oh man, my little indicator went away. Oh, there it is. So, so kind of in this situation, this is a diagram that shows that the footer and the deck post has been installed on disturbed soil. And so a lot of times if you have, if your footing is on disturbed soil, that soil is going to settle over time. And then this deck will start to angle back towards the house, which is this diagram. The settlement of soil located below a deck can pull the deck away from the ledger attached to the house. A freestanding deck is not attached to the house. The illustration shows a freestanding deck with one of its posts resting on disturbed soil, as I just mentioned. Um, and the top right illustration here is depicts the 7-foot rule. So on steep properties, the slope of the ground around the footing could affect the footing stability. The 7-foot rule states there should be at least 7 feet between the bottom of a footing and daylight. Um, Also, there's something that is not in this class, but it's also in engineering and structural engineering. It's called the cone of compression, and so you want to make sure that even though you have a footing, that footing is actually still being supported by the earth. And so kind of how you take the angle, and this is just very rough, so bear with me, but you kind of take the angle, the similar angle that you see on the footing here, and you have to draw that down to make sure that the earth below that is not being, is not disturbed, and there's not any erosion that's happening around that. So that's very common that we see on decks and stuff, especially when gutters are terminating near that location and can start to wash away the earth that is supporting that footing. All right. Bottom of the deck post. So the bottom of deck post must be restrained to prevent lateral displacement. The lateral restraint may be provided by a minimum post to footing connection based on the manufacturer's requirements, or connections supplying lateral restraint, or by embedding the post at least 12 inches into the soil or concrete piers. Posts in contact with soil should be pressure treated. If you're concerned about that code or you want a code reference for that, you can go to the 2021 IRC 507.4.1. Posts should be connected to their footing so that the posts don't lift or slip off. Often the bottoms of the stringer boards for deck stairs have been found to rest on soil, concrete block, or rock, as opposed to resting on posts installed below the frost line. Posts set on soil are subject to rot and movement due to moisture. Posts that are set in unsound footings may cause movement and make the deck above unstable. So these are all very common supports. This is your classic, so this diagram in the middle, this is your classic precast concrete support. Oftentimes you will find these concrete supports are being used as footings, which is not correct. Those these precast concrete supports are generally only intended for freestanding decks that are not attached to the house. That's why you have these grooves that are cut in the side or were formed in the side, so that the beams or the joists can run through those. And then so it kind of takes the place of a post when you want to put the deck on the ground or close to the ground. So like I said, you will find these a lot. I find these a lot in my area where people that are getting into deck building, they just see these in the store and they think, oh yeah, now I don't have to dig. I don't have to pour concrete. I don't have to put a gravel base down. We can just put this on. And then even in my area, we have a very low frost line. And so even when our frost line is not really low, you still have moisture that is going in and out of the ground throughout the year, which raises and lowers, that's earth. And so that can cause your deck to be all wobbly when you don't have, when you're not setting it on undisturbed soil, below grade, below the frost line. Oh, let me go back here. Okay. So high decks. This image to the left depicts a high deck being supported with 4x4 posts. Tall 4x4 posts twist under load, and 4x4 posts, even when treated, decay below grade too quickly. As a general rule, for all but the lowest decks, deck posts should be at least 6x6 and no higher than 12 feet. 14 feet is acceptable if cross bracing is used and the posts are 8x8. Posts that are 4x4 can be used for heights up to 14 feet, but only under very specific circumstances. My last house before we moved into this house that I'm in currently, we had a deck almost identical to this one on the house, and it was very sketchy. The posts were twisting, they were 4x4s. We did have diagonal cross bracing under the deck posts that stopped the deck from racking back and forth, which we're going to talk about here in a second. But But we did, when we sold the house, the homeowners bought the house as is. It was a very hot market and houses were going like crazy. And so they didn't require any updates or repairs or didn't ask for any anyway. But we do on occasion like to drive by that house and go see kind of what the situation is. And and they decided to put a blow up hot tub on top of that deck. And now the deck hasn't fallen off yet, but they are in a very precarious situation. So, and it is like, I think the deck was probably 16 feet off the ground, which is super sketchy and very scary. So, um, moisture and wood decay. So wood can decay and degrade over time with exposure to the elements. Decay is a problem that worsens over time. Members within the deck frame that have decayed may no longer be able to perform the function for which they were installed. Paint can hide decay from an inspector and so should be noted in the report. Inspectors should know that painted deck posts can hide and cover wood decay. And then cracks. As wood ages, it's common for cracks to develop. Large cracks, longer than the depth of the member, or excessive cracking overall can weaken deck framing. Toe-nailed connections are always at risk for splitting. Splitting of lumber near connections should be noted by the inspector. And I'm sure if if you seasoned inspectors, or even if you've been around, a short amount of time, it's very common when you have, wood trim that's on the outside of the home, and somebody, especially when they're going to sell or flip the home or whatever, it's very common for those people to come in and just paint all this rotted wood. So, be very careful when touching exterior wood trim or any exterior painted wood to make sure that you're not going to cause an unsightly damage by pushing your finger or your tool or your whatever through there. For me, I just go through and I gently press on to kind of determine how deteriorated the deck or the wood is back behind the paint. But you don't want to do, you don't want to do damage to the home. So just be very careful, pay special extra attention. And if you can, test an area that is, may not be affected or is hidden or is not in the structural area. That's generally where I like to show in my pictures, definitely exterior painted wood is rotting behind the paint, and like to show, the evidence of that. So pay special attention to sprinklers that spray on decks. If you do see a sprinkler that is spraying on the deck or has sprayed on the deck in the past, that is definitely something I would recommend to be adjusted, and the sprinkler to be directed away from any wood at all. Look for sinking around around any posts. Again, it's very common to, put the post in and then you just pile the dirt right next to it. But then over time, that dirt settles and then you create like this little concave area where water likes to sit and then will exacerbate the rotting of the posts. And then again, kind of like I said over here, and this is very common. You're going to find this all the time, especially when the deck is wrapped around the gutter downspout, where they built the deck around it, but then they never extended the gutter out from away from the deck or out away from the support posts. So definitely, call out that kind of stuff and make sure that the homeowner is aware of it. And if you can get to that area, probe, do your awl, do your pick tests. All the things that you need to do to make sure that that deck is still sound. And just as I mentioned, here's a demonstration of the pick test. So the pick test is an ice pick, an awl, or screwdriver. After penetrating the wood, the tool is leveraged to pry up a splinter parallel to the grain away from the surface. The appearance and sound of the action is used to detect the decay. The inspector should first try the pick test in an area where the wood is known to be sound to determine a control for the rest of the inspection. Decayed wood will break directly over the tool with very few splinters and less or almost no audible noise compared to sound wood. The pick test cannot detect decay far from the surface of the wood. Girders and beams. So untreated joists should be at least 18 inches away from the ground. Girders and beam plies should be 12 inches away from the ground. However, in many situations, exceptions are made where the elevation of the home does not provide, does not provide for these minimum distances and the climate is very dry. Beam plies should be fastened together with 2 rows of 10D 3-inch nails at a minimum of 16 inches. So we're talking about, well, these beam plies here, right? Sorry, 2 rows of 10D 3-inch nails at a minimum of 16-inch on center along each edge. You can refer to the 2021 IRC 507.5 for that. So, and this is not something that we'll probably, I don't think I have a slide for this later, but talking about treatment of wood, and I know you can't read this, but this is a very common tag that you're going to find on treated wood or on any wood. You'll find this, but will have different markings on the top of this. And sometimes this is the only way that you are able to like 100% identify that how the wood has been treated or either pressure treated or heat treated or whatever. The Like I said, so unless you can tell by the color, which can oftentimes be a light blue or a light green, or you look at this tag that is generally on the end of that piece of wood, is a lot of times is the only way to truly identify if it is ground contact rated or pressure treated. And then so what you want to look for, if it on this one it specifically says ground contact general use. If that is not there for whatever reason, then you should be able to reference. There's a code that's in that tag, and it's called UC4A, and that is the designation for pressure treated or for ground contact rating. And then, like I said, I don't know if you can see this very much, but instead of being a yellow color, so this is a pressure treated piece of wood, and I'm going to talk about the stamp here in a second. And I don't know if you can see. Make sure that you guys can see. Okay, so this color, this wood, obviously it's brand new. It hasn't been weathered, but it does have a very light greenish blue tint to it, and that is the indicator that it is a treated piece of wood. And then you have the stamp up here, and a lot of times the stamp doesn't actually say that it's been pressure treated, or this stamp doesn't say. Some manufacturers will put that it's been pressure treated, but this manufacturer does not. It does say that it's been heat treated though. And then, so in the middle it has an HT, which means heat treated. On the far left over here, it has a KD19, and that means kiln dried at 19% moisture. Then we have an SPID, I think, but that's the genus of the wood. So this is a southern pine. And then you have number 2 prime is the appearance grade, and then the mill number, which is the 146, and this is where the wood was milled from. And I believe this one's in Seattle, 146. All right. Let's see. I think we hit everything on that. Oh, I'm sorry, I didn't hit on this stuff. So so you have your clearances over here, right? 18 to the joist, 12-inch to the beam. These are just making sure that you have positive connections from your post to your beams. And these are probably Simpson strong ties, some type of fastener. And then the remainder of the notch post should be at least 2 inches thick. So we're going to get into this here in a little bit. But about why 4x4s are not recommended for support posts, and that's so you have enough meat on if you decide to notch that post, you still have enough meat that is still going to be considered structurally sound. And then over here, girders, this is very common on the right-hand side diagram over here where, and we still, I see this on a lot of older homes, even up to 15, 20 years ago, this is still very common. So those decks are all still existing, or a lot of them are. But what you'll find here is where these beams have been attached to the post, and they're just using lag screws something like that. Oftentimes, because these are not sitting, all that weight is being carried by that screw. And on top of that, the water penetration is starting to follow that screw or follow that, that lag screw into the support structure and will start to rot out that wood in those locations. So we'll get into this a little bit deeper here in a second, but just keep that in mind that you will see this out in the field. It is no longer acceptable for in new construction. All right. So this guy over here on the top left, let's see, okay. So the illustration on the left, top left, depicts a butt joint or a splice improperly located within a girder span. Butt joints in a girder span are generally not permitted unless specifically engineered. A butt joint or splice should be positioned to land on the posts. Notches in solid lumber joists and beams must not be greater. So we're talking about this diagram over here, and specifically this guy right here. So notches in solid lumber joists and beams must not be greater than 1/6 the depth, must not be longer than 1/3 the width, must not be located in the middle third. So nothing in this middle third. And notches at the ends must be less than 1/4 of the depth. So you're looking over here, right? Notches on the ends, 1/4 of the depth. And the tension side, which is the bottom side over here, of beams 4 inches or greater in nominal thickness must not be notched except at the ends of the beams. The diameter of holes bored or cut into joists or beams must not exceed 1/3 the depth here. Holes must not be closer than 2 inches to the top or bottom of the joist or beam, or to any other hole located in that member, or to any notch in the beam or joist. And then the right illustration depicts a level being used to check for beam sag. Even with a carpenter's level, it can be difficult to see beam sag from the front. The image depicts beam sag being eyed up. So if you're looking along the length of it over here, often it's easier to detect beam sag by the eye than with a level by looking onto the bottom, by looking along the bottom edge of the beam. A lot of times when you have a long span like that, if you try to use a level, the deflection might not be great enough because generally you can only carry about a 4 to 6 foot level in your truck, right? So 4 to 6 feet, and you have a 30-foot long beam or whatever you're gonna, or whatever distance you're gonna have, you might not be able to see that deflection or that bowing, but you will be able to see a lot better if you look along the bottom edge of it along the length. All right, ledger connections. The most common cause of deck collapse is when a ledger pulls away from the band joist, of the homes or the building. The two most common ways to correctly attach a ledger to a structure are with lag screws or through bolts. The installation of through bolts requires access to the back side of the rim joist, which in some cases is not possible without significant removal of drywall within the structure. Determining the exact required space for the ledger fasteners is based on many factors, and so generally is beyond the scope of a visual inspection. But for your general knowledge, assume a deck is built with a 40 PSF live load design. The joists span 10 feet and a half-inch diameter lag screws with washers are used. The on-center spacing of fasteners is 18 inches. The tip of the lag screw should fully extend through and beyond the inside surface of the band joists. So here is your lag screw, right? And you should see, let me see here. So coming out the back side of that band joist, you got to see the full width of the shaft. So you shouldn't just see the tip, right? You shouldn't just see that poking through your band joist. You should definitely see the full width of the lag screw coming through that band joist, if you can see it. A lot of times you won't be able to see that, but if you have an opportunity to see it, for instance, we see a lot of that we have very high, we have a lot of walkout basements and a lot of very tall crawl spaces in my area. And so if the floor is not insulated, which is very common here, because we're in a very mild climate, it is required now, but existing homes do not have it. So if you see how the deck ledger has been attached to the home in the crawl space, no matter what, you should see those fasteners coming through. Now, uh, sometimes the floor structure is constructed in a way where you can't see that band joist from inside the crawl space. But if you have an opportunity to see the band joist from inside the crawl space and you have an attached deck structure, there's guaranteed you've got to see the mounting hardware coming through that band joist. Let's see. Sorry, I got all right. Okay, so InterNACHI's ledger fastener spacing formula provides inspectors with a general rule of thumb. So on center ledger spacing of a 1/2 inch lag screw with washers, you could take 190 and divide it by the joist span in feet, and that should give you your very rough estimate, but that should generally give you a good idea of where you should be seeing or what the distance is between your lag screws in that instance. And then for lag bolts, you do 330 divided by the joist span in feet. And then you should, again, get that general distance from connection to connection. Lag screws and bolts must have washers and be installed through the ledger board in a 2-row staggered pattern, staggering from the top to the bottom along the horizontal run of the deck ledger. The placement of lag screws or bolts at the deck ledger should be 2 inches from the top edge and bottom edge, and 3/4 inches from 2 inches from the top edge, 3/4 inches from the bottom edge, and 2 to 5 inches from the ends. So again, if you're seeing mounting, seeing lag screws or lag bolts, they have to have washers. Again, kind of for the main part is, over time, the wood deteriorates, the deck deteriorates, and water likes to flow in between, and follow these connections. Into the mounting structure. And so over time, the wood is going to decay and deteriorate. And so these washers are super important in making sure that the deck lasts, its intended lifespan. Without them, the deck and the ledger can pull through, and then you can have a potential deck failure. Oh, so band joists supporting a ledger must be 2-inch nominal solid sawn lumber or a minimum 1-inch nominal engineered wood rim boards. You can refer to the 2021 IRC 502.1.7 for that code. The tips of the lag screws must fully extend, as we stated already. And then the adjacent code, which is the 507.6.1, states that deck joists that connect to the side of a deck beam or ledger board must be supported by approved joist hangers. Deck ledgers should be made of at least a 2x8 pressure treated wood. And then the illustration depicts a floor joist resting on a 2-inch 2x2 ledger strip. And then you have another one depicts a notch joist resting on a 2-inch by 2-inch ledger strip. And then over here, the illustration depicts joists properly attached to a ledger using metal joist hangers. Now, don't pay attention to this little guy over here, because obviously, as per our last slide, these should be staggered. And then well, we don't know what the spacing is, but they definitely should be staggered and going up and down in kind of a W pattern across that ledger board. So while these three over here were very common in attaching joists to ledger boards, also what you're going to find in the field is blocking. So this piece of wood Instead of so before, the metal joist hangers became common, you used to put, you had a joist, another joist, you would block, you would attach blocking in between. So you would nail, you would nail for the joist into the joist into the blocking, and then the blocking is attached to the ledger board. This is very common configuration in my area. But like I said, on new construction, you don't find this anymore. You only find joist hangers, but you will find this a lot in my area. And on addition, so we're going to get into this in a little bit, but you have the brick veneer and the ledger board attached directly to the brick veneer, and that is also a no-no because you don't know, brick veneer is not structural. So how exactly is the structural soundness of this deck being supported by the house? Like I said, we'll get into that in a second. In addition, I wanted to point out these joist hangers. So a lot of inspectors, and myself included, I used to call out incorrectly sized joist hangers until I read the installation instructions from Simpson Strong-Tie on these joist hangers. So a lot of times a joist hanger will have two approved joist sizes. So for instance, this one, so if you read on the bottom of this, which I know you can't read that, but if you see the stamp, which maybe you can see that a little bit, but the stamp on there, if you look this up, it has the Simpson Strong-Tie, and then it has the model number, which is LUS 26Z. So that 26 is indicative of a 2x6. Now that is the smallest size rated for this joist hanger, but this joist hanger can actually go up to a 2x8 also. So just be wary if you want to call out incorrect hanger sizes. Make sure that you are reading or you're looking up the model number to see what exactly it can support. So like I said, so this one is rated for a 2x6 and a 2x8. This guy is rated for a 2x8 and a 2x10. And this is rated for a 2x10 and a 2x14. And so you can kind of see the differences in the sizes here. So just pay special attention if you're going to be calling that kind of stuff out. Make sure that you're doing your due diligence and you're making sure that it is not, in fact, because I will be very frank. I definitely called it out when I was not accurate, and so I had to kind of eat some crow whenever we had to talk with the builder and the buyer for the home inspection and admit that I was incorrect in my observation. That was a long time ago, though, so just to keep that. All right. So a couple more diagrams. So joists must be cut long enough to reach the ledger or the band joist that is supporting them, and joists should be fully resting in the joist hangers. So again, if you go and you read the Simpson Strong-Tie installation instructions, I believe they allow for a 1/4 inch. So kind of the distance that you can see, this kind of angled area. So basically, the joist can come right, because if you were to push the joist, let me see if I can find something better to. So you can see there's a gap here where if you push the joist all the way up and flush with the mounting flanges, then you're going to see, you're going to be able to see that deck joist. It is allowed in the Simpson Strong-Tie installation instructions that you can just come up to this edge. But if the deck joist is coming any further back than this edge, then that does not meet the installation instructions of the Simpson Strong-Tie, and according to their documentation, it will not support the joist as much as it was intended to. And I have some really good pictures that I took at the very end of this presentation, and it's a lot of fun. You'll be able to see. So, in addition, it's very, very common for contractors to also modify these joist hangers. So if they are trying to level that deck, a lot of times they'll take a hammer and they will just hammer the bottom of the joist hanger up until the joist becomes even with the band joist. So you'll see that, or you'll see it where they'll use probably they bought a huge box of these, and instead of buying a correct like a hanger for a double joist, they will just hammer this flat and then try to hammer it back around a double joist or a beam, and then use this as a hanger. So they'll buy oversized single joist hangers and they'll try to modify it for a double joist hanger. So you'll see that. And then in addition, on these guys specifically, every mounting hole should be filled. So it's very, very common that you'll find that contractors will just fill the flange side and not the joist side. Or let's see, what else will you find out in the field? Definitely missing fasteners, incorrect fasteners. So when you're dealing with pressure treated wood, it as a corrosive, the pressure treatment of the wood can cause corrosion in different kinds of metals, specifically aluminum. And so you want to make sure that you're using galvanized fasteners, stainless steel fasteners, fasteners that are specifically coated to be able for pressure treatment contact, which with the advancement of technology and coatings, you used to be able to tell the difference between hardware just based on the color or the sheen of it. Anymore, you really can't tell that information anymore. They've come out with multiple different kinds of coatings with multiple different kinds of coloring and all that stuff. So, and you'll see at the end, I have a couple of explanations of this where really the only way that you can tell if a hardware is rated for, unless it's obvious. I mean, this is obvious, but unless it's if it's not obvious, it has a coloring or a coating, and you can't 100% tell. Many times the only way to tell is if you can find the box on site somewhere that it came in. Other than that, it's very, very hard to tell. All right. Ledger board and band joist contact. Okay, got 10 more minutes here and we'll take a break. Let's see, ledger board and band joist contact. So the image to the right over here depicts a ledger board and a band joist sandwiching the structural sheathing. Sheathing is permitted to be wood structural panel, gypsum board, fiber board, lumber, or foam sheathing. The 2021 IRC 507.9.1.3 subsection 1 for ledger connections allows up to a 1 inch of open space between the house band and the ledger. This provides for wall sheathing and or drainage and ventilation. It is not intended for cladding. So just your standard exterior cladding cannot be sandwiched in between the ledger board and the band joist. It's kind of like we were talking about with the brick veneer. You cannot have brick veneer sandwiched in between these two. The correct way to attach those is that the brick would be removed, the band joist attached through the sheathing, and then everything flashed and protected in those areas. If they don't want to do that, then technically it should be a freestanding deck. So up to 1/2 inch thickness. Let's see. Code in some areas outright forbid attaching. Oh, I can't see my wording down there, but I guess you guys can. I don't know how to get rid of that. Oh, they specifically forbid attaching to open web floor trusses. So if you have open web floor trusses, or you have manufactured I-beams, then a lot of times you have to have additional wood structure on the outside that is solid, where you can attach the band, or you can attach the ledger board to the band joist. So if you have floor trusses or manufactured I-beams, make sure you pay special attention to the band area inside. Generally, you're only going to be able to see this in a crawl space, but inside of a crawl space, pay special attention. So I've seen where they take, and in my area, this happens all the time, where they'll take an manufactured I-joist and they'll use it as the band joist. But then when they attach the deck to the house, then they put additional, either well, what's it called? We have the, oh, I just lost my train of thought, but we have the manufactured beams. And so you'll have two I joists side by side that are making up the band joist area. And then if you're going to have a deck attached to that, then you have to run solid wood in between those I joists. And then that connector has to run all the way through it. Lamb beam. That's what I was the lamb beam. So you'll have to have the lamb beam that's installed there too. Sorry. All right. All right. Probably, so let's see. So the top right picture here. So the deck, the top right image depicts a ledger board improperly supported by brick veneer. Ledger boards should not be supported by manufactured stone or brick veneer. Deck ledgers are not permitted to be supported on stone or masonry veneer. So again, if to be properly done, the brick would have to be, you'd have to have an intersection, everything attached and flashed correctly, and then the brick could continue down below. Again, this is very, very common. Our code officials out here do not call out decks attached directly to brick veneer. They just, for whatever reason, they just don't. So you'll see this a lot in the field. Pay very close attention to brick veneer and deck attachments. And then so over here on the left, the ledger board attached to a concrete wall, caulking rather than flashing is used because there's not really, you don't have the ledger board that is attaching to wood structure. So you don't have to have, flashings and all those things. And then just, putting a bead of caulk. Nope. Putting a bead of caulk is just to help water from getting trapped in between the ledger board and the concrete, which if it, because water likes to stay in those trapped areas, and if you don't have airflow going through there, it can cause some moisture deterioration, especially where the penetration is going from the ledger board into the concrete, because your pressure treatment should be all the way through that wood, but because it does give it more area and there's no airflow through those connections, it's very common to see rot and deterioration at those connections there. And then when you have hollow core, so when the ledger is attached to a hollow masonry wall, the cells should be grouted. You'll find this, and I have a great example of this at the end of the presentation here, where they used wedge anchors and they thought they were doing a good job, but they used wedge anchors and the cells were not grouted. And so what we ended up finding is that because how they penetrated through the CMU, you started to crack, and you have spider cracks coming off here. All that weight that was being supported by the ledger board and that fastener is pulling on that thin wall, which is why you have to have grouted cells in CMU walls when you attach a ledger board to them. They do have a special epoxy now. So you have approved epoxy and acrylic anchors. But again, you got to pay special close attention to, if you're going to use those, it should still be in grouted CMU walls, even if you are going to use the epoxy connection material. And yeah, here, we'll hit this. We'll probably talk about this more after we come back, but ledger board flashing. So ledger flashing is intended to divert moisture away from wooden components of the house. A deck ledger connection is only as strong as the wood it is attached to, and rotted wood is not strong at all. Ledger flashing is only required for decks attached to wood frame construction. Since the ledger board is required to be decay resistant, the flashing functions primarily to protect the house. Ledger boards attached to concrete foundations do not require that type of flashing, and durable sealant is recommended. And then the illustration, the picture depicts a flashing installed over and under the ledger board. The ledger board should be flashed even if the home has protective roof overhang. Aluminum flashing is commonly available but should not be used. Contact with pressure-treated wood or galvanized fasteners can lead to rapid corrosion of aluminum. So yeah, let me hit on a few things real quick and then we'll take a break. So what you're gonna, a lot of times what you're gonna find in the field, I have, I've done over 6,000 inspections, and this bottom flashing I have never seen, not one time. Um, and even on a full framed wall, it's just not there. And even on covered decks and uncovered decks, it's just not done in my area. And again, the code inspector does not call out missing flashing. They don't even call out missing flashing on the top of the ledger board for decks. So it kind of comes down to us to be able to call those things out. I have a specific instance where I did an inspection, new construction house, $600,000 home, beautiful 3-story, had a 2-story deck on the back with a patio, and so it was roofed over that section. I had no flashing on the ledger board at all, and again, we're in an area where construction is crazy. We have multiple offers kind of type situation. And so when I called that out, the homeowner asked the builder to update it, and they just flat out said, no, we're not doing it. The deck is covered, and and to us that's acceptable. And you always get that, well, the code official didn't call it out, so it's okay. So what ended up happening, the homeowner still bought it, but then they ended up hiring their own contractor to come out, and they took this bottom board up, or this first board up, and then they had their own flashing installed, but they were only able to do it on the top of the ledger. All right, we're gonna get back into it here. So we're gonna hit on some stuff I'm gonna talk about, but kind of how we had talked about in the previous slide. You have this exterior structural sheathing. That's this red part of the diagram. So that is allowed to be sandwiched in between the ledger board and the band joist. So this is the ledger board. This is the band joist of the house. And so, so again, you can, but if the siding, the green portion extended all the way down, then technically that is incorrect and should be recommended to be adjusted. All right. And I know we have these two lag bolts or lag screws that are right on top of each other, but I think they did that so that you can tell, definitely you will see this all the time out in the field where you have the connectors on top of each other. And, I would not necessarily, for myself, for my own clients, as long as there's no deterioration, everything is in good working order, the deck is operating as intended, I would not make a big deal about that on existing decks. But on new construction or on a deck been recently built, I would definitely call out that the bolts or the screws are not staggered, and then and then address the spacing and stuff too. All right, here we go. Next slide. All right, overhangs. So band joists attached by a ledger must be fully supported by a wall or a sill plate. Many deck failures have been attributed to a cantilevered floor rim joist pulling away from the house or shearing downward. Band joists are just nailed. Band joists are just nailed to the ends of the floor joist without any direct support beneath the band joist. The nails alone cannot support the load from the deck and is attached to it by the ledger board, or that is attached to it by the ledger board. I don't so much see this very much anymore, but I definitely used to. It definitely, it used to be common to attach your ledger board directly to a bay window or some type of overhang, things like that. And I actually, I use InterNACHI's diagrams a lot in my reports, and so this diagram came in very, very handy, showing how the structure should have been supported instead of being directly attached to the bay window. So standards have not permitted deck ledgers to be connected to the rim joists of cantilevered floors for many years. Illustration depicts proper framing around chimneys, cantilevered floors, and bay windows that are up to 6 feet wide. Framing around the chimney, there we go. Framing around chimneys, cantilevered floors, and bay windows that are more than 6 feet wide requires additional posts. So you would often find, or you should find, a support post. If it's wider than 6 feet, you would find support posts at these locations. So if it's longer than 6 feet and there's no support posts, definitely recommend that. And if it's working as intended, I guess that's where we as home inspectors kind of we have that gray area. We want to protect our clients. We want to do what is good and right for them, without being the deal killer. All right, spans and cantilevers. So calculating spans and cantilevers for deck beams and joists is beyond the scope of a home inspection. But a home inspector should know what is a beam span, a joist span, a cantilever, and how to divide by 4. For joist bearing on wood beam, at least 1.5 inches of bearing length of the joist is required. The old rule of thumb was deck beams can cantilever at each end up to 1/4 of the actual beam span. Joist span does not include any bearing area, but only the open space that is not bearing upon the beam. Home inspectors may refer to the old general rule of thumb during a home inspection because home inspectors are not code inspectors and are not required to refer or quote code, including this information about the deck joist cantilevers. The illustration to the left shows a deck joist cantilever in front of the deck and the deck beam cantilevers on each side of the deck posts. Beams are permitted to cantilever at each end up to 1/4 of the actual beam span, so the span divided by 4. The deck joist should be cantilevered according to the 2021 IRC Table 507.6 for maximum deck joist spans and maximum cantilevers. So the code kind of changed a little bit, and so it's gotten a lot more specific and detailed. So if you want to, call out overspanned cantilevers, then technically you're going to have to refer to the code, to accurately call those things out. So if that's something that you do on the reg, then definitely keep this table in mind and refer to it in your, just refer to it in your evaluation. So for instance, let's assume the deck is built with a 40 PSF live load design. The joist species is spruce pine fir. The joist size is 2x10, and the allowable joist span is 13 feet 7 inches with joist spanned space 16 inches on center. And so you have the maximum cantilever of 3 feet in that instance. Connectors and fasteners. So deck joists must be supported by approved joist hangers. The inspector should note missing connectors or fasteners. All lag screws should have washers. All bolts should have nuts and washers. Depending on how the deck was built, vital connections may have degraded over time due to various factors. Issues such as wobbly railings, loose stairs, and ledgers that appear to be pulling away from the adjacent structure are all causes for concern. The tightness of fasteners should be checked. It is not possible, if it is not possible to reach both sides of a bolt, it may be struck with a hammer. The ring of the hammer strike will sound hollow with vibration if the fastener is loose. The ring will sound solid if the connection is tight. The hammer test is subjective, so the inspector should hammer test bolts that can be confirmed as tight or loose and compare the sounds of the rings to develop a control. All metal mounting hardware should be hot dipped galvanized, stainless steel, silicon bronze, copper, zinc coated, or corrosion resistant. Metal connectors and fasteners can corrode over time, especially if a product with insufficient corrosion resistance was originally installed. Corrosion of a fastener affects both the fastener and the wood. As the fastener corrodes, it causes the wood around it to deteriorate. As the fastener becomes smaller, the void around it becomes larger. Kind of going back to the ledger flashing, it is extremely common. So when a contractor who is not familiar with the deck code standards, and they go into Lowe's, they were subcontract or they were hired to do a deck build, and they're not familiar with the materials and the processes. A lot of times they have never read the code. They never read the standards. They don't know what the DCA 6 is, which that's just a kind of a condensed version of all the different standards. It's currently out of date, but it's good information to know. But a lot of times you'll see where they just bought a roll of the cheapest flashing, which is aluminum, and then they use that as their ledger flashing. Well, if you go to a deck that's been, 5 to 8-ish years old, the pressure treatment or the chemicals that was used in that, you go underneath that deck and you'll see that the metal, it looks like it's rusting away, but it's just, aluminum doesn't really rust, it's just corroding away. And so you touch it and it just falls apart. And if you ever see that, definitely call out, aluminum flashing used incorrectly with pressure treated wood and pressure treated structure. So again, kind of going back to your mounting, your hardware, all that stuff. There's so many different kinds now. Just really, you got to look for, and kind of what I was going to state in that other, when I lost my train of thought there, was that, we're not, we have that gray area where we're not code inspectors, and we're technically only, per our SOP, supposed to call out damage or deterioration, right? So we're in that area where, if something is not completely degraded or something's not degraded at all, especially in new construction, generally our SOP states that we don't have to identify that. But if you want to offer, more value for your customers' money, then you can start to call out some of these things if you're comfortable doing so. Just be aware that, like I said before, when the contractor or the builder comes back and they say, "Oh, it's the code," for me, I would be like, "Well, it's not the code. I can prove it," but there's got to be that separation somewhere in there. You can't go and fight everybody. You gave the information that was proper to the client, and then they have to do with that information however they want. It's not up to us on how they use the information that we put out there. So just put that information out there if you're comfortable doing so, and let the cards fall where they may. So David asked, could you say something like the cantilever span appears to be excessive? Recommend further evaluation by a licensed contractor? Absolutely. That would be on new construction. If I thought that something was overspanned or, cantilevered over, or the distance for the cantilever is greater than it should be, that's a great comment, especially on new construction. But on existing or older construction, kind of like I said, we're in that gray area for we as inspectors, where if you call out, you go to the span tables and you look up the species of the wood and the spacing, and you determine all that kind of stuff. That's kind of, it's definitely going above and beyond. But on an existing deck, if it's over, if the cantilever is too long or it's too big, then you should see a sag in that. Because the minimum standards in the code are to prevent that sag from happening. And so if you have sag at all, so if the deck doesn't meet minimum code standards, then technically, because it is the minimum standard, you should see some type of defect associated with that. So if you have a cantilever on an existing deck, it's been around for 10-15 years, and you do feel like it is the cantilever is too big, then you should see a deflection or a drop in that cantilever, showing that the span was too great. So that's generally where I use my evaluation or do my inspection from that standpoint. So there's a lot of things where in construction, a lot of things are kind of subjective. My dad and I, whenever we were building and remodeling, we always I had never read a code book. I had never done any of that stuff, but we always over-engineered our construction stuff when we were remodeling or installing stuff on our own homes. And so if an inspector were to come in and evaluate our stuff, evaluate our installation practices, and this was 20 years ago, but you would probably definitely see a lot of stuff that would not comply with code, but because we over-engineered it, it was still working as intended. So you just have to use use your own determination and just make sure that your clients are going to be taken care of in the future. All right, lateral connections. Lateral loads shall be transferred to the ground or to a structure capable of transmitting them to the ground. The IRC requires decks supported by the attachment to an exterior wall to be positively anchored to the primary structure and be designed for both vertical and lateral loads. The vertical and lateral loads referred to are code prescribed loads such as dead, live, wind, and seismic loads. Attachment only to the band joist may not be sufficient for the lateral loads. Positive anchorage of the deck joist to the house's floor framing, as shown in the the left figure here. Let's see. Positive anchorage to the deck joist addresses this potential failure. Excuse me. You can refer to IRC 507.9.2. Where lateral load connections are installed at the deck, the inspector should observe hold-down tension devices installed in at least 2 locations per deck, and they should be installed within 24 inches of each end of the deck. For new or replacement decks on existing homes, builders or homeowners must often remove the interior wall or ceiling covering in order to install these large hold-down tension devices. Another type of lateral load connection that is permitted to be installed at the deck are surface mounted and should be installed in at least 4 locations per deck, with one at least 24 inches from the end. So that's talking about this little metal piece right here. These devices achieve an acceptable lateral load connection between the deck and the primary structure, with the installation of these surface mounted hold down connection devices that are spread out along the length of the ledger and do not require opening up the interior wall or ceiling spaces nearby. These devices provide a positive connection to the floor framing in order to resist the lateral loads. This is something that has not been implemented in my area yet, but I cannot wait to see them. I think there's probably going to be a lot of pushback from the builders when this ends up being required in my area. I don't know if it's required in your area or not. Bracing. So the top left image, depicts a deck with post to joist diagonal bracing. Decks greater than 6 feet above grade could have diagonal bracing from post to girder and from post to joist. Diagonal bracing is required in some older building codes that didn't require lateral bracing. Deck post bracing that is installed in addition to required lateral bracing is not a defect. The right image depicts a deck to post to girder diagonal bracing. Deck with post to girder diagonal bracing. Freestanding decks not supported by the home or the building should have diagonal bracing. The middle illustration depicts the underside diagonal bracing of a deck floor structure. Decks greater than 6 feet above grade could have diagonal bracing across the bottom of the joist to keep the deck square. A deck that is not held in square could permit the outer post to lean to the left or to the right, to the left or to the right or to the left, parallel to the ledger board, and thus twist the ledger away from the home or building. So this, that diagonal bracing prevents the deck from racking back and forth, or helps to prevent the deck from racking back and forth. So keep an eye on that. So really, if you're on a deck if you're on a deck and you can sway your body side to side and you feel the deck kind of sway side to side, it's likely because you are missing some of these bracing components. All right. So let's watch so this is a great flashing diagram, great flashing video, and let's see if we can get this to work.
The ledger board should always be flashed, even when the home or building has a protective roof overhang. Here's a typical installation sequence for the deck ledger flashing. We painted this red. This is the sheething. This is the house wrap or building paper. Now the exterior wall covering below the deck. The bottom Z flashing, counter flashing, sometimes a self-adhesive membrane, the ledger board itself, the top Z flashing, counter flashing that overlaps the Z flashing, and the exterior wall covering, which overlaps the counter flashing. Aluminum flashing is commonly available but should not be used. Contact with pressure-treated wood or galvanized fasteners can lead to rapid corrosion of aluminum.
Well, I'm gonna go back to that video. I love that video. It does show exactly how everything should be layered, but there's, in the real life, and a lot of times you're going to be missing some of those counter flashing locations or that bottom Z flashing for sure. But you can definitely call that stuff out. I do on all my decks because I don't want my customer's deck to fail or for them to have water intrusion. But a lot of times you're going to get a lot of pushback from your builders or your contractors on adding those components to the deck structure. All right, so where guards are supported on deck framing, so in like these situations, right? So where guards are supported on deck framing, guard loads must be transferred to the deck framing with a continuous load path to the deck joist. The guard must connect to the floor joist, not the outer rim or band joist, which is this is fairly new. So at least in my area, it's fairly new. Where guards are connected to the interior or exterior side of the deck joist or beam, the joist or beam shall be connected to the adjacent joist to prevent rotation of the joist or beam. If the guard is connected along the exterior joist, it must be connected to an adjacent joist. Otherwise, the single joist connection will rotate and won't support the guard above adequately. Connections relying only on fasteners and end grain are not permitted. Again, so I have real life pictures of this at the very end of this presentation that I can't wait to show you in relation to this this diagram right here, where they did this. This is a 4x4 post, and there's a big old crack going right up here. And so, if you were to put any weight against this this guardrail support post, it would break completely off. Where guards are mounted on top of the decking, the guards must be connected to the deck to transfer the guard loads to the adjacent joist. The right image depicts a notched deck guardrail post attachment. This common notch type of attachment was permitted by most older codes, but is no longer accepted as of the 2021 IRC. Newly notched posts are a defect. Notched guard posts, specifically 4x4s, attachments could become loose and unsafe, especially as the deck ages. Code now requires that the connection extend back into the framing in some manner to prevent a guardrail from pulling a rim joist off the ends of the joist or from rotating a single side of the joist. You can refer to IRC 507.10. While graspable stair handrails are meant to support us and must resist forces in all directions, guards that wrap around a deck are only meant to keep us from falling off the edge. According to 2021 IRC, guards will no longer be required to resist forces pulling inward or upward, just pushing outward. Leaning on or sitting on top of a guardrail is common, so it must be able to support the load. Guard and handrail design loads and load direction are separate and different. The concentrated load direction for guards and handrails used to be in all directions. Now it's only in outward and downward directions. So guards, a concentrated load of 200 pounds per square foot, outward and downward. If the top of the guard is not serving as a required handrail, the single concentrated load could be applied at any point along the top, in the vertical downward direction and in the horizontal outward direction away from the walking surface. Where the top of a guard is serving as the handrail, a single concentrated load could be applied in any direction at any point along the top. So inspectors should really wiggle those handrails. So basically, if there's any movement, in that handrail, it really needs to be shored up. I'm a big guy, and so if a lot of times for me, I have to gently push out, because if I pushed as hard as I could, a lot of these decks that are older, a lot of times I would probably be able to break those posts off. So um, uh, just pay special attention to that. And definitely, if you feel it wiggling, it needs to be called out and recommended to be shored up for the safety of the homeowner. Um, While handrails are graspable and can be pulled in any direction, a guard is not required to be pulled or pushed in any direction, just down and out. Because of leverage, a 200-pound force pushing the deck's guardrail outward causes 1,700-pound force at the upper bolt attaching the post. It is difficult to attach deck guard posts in a manner that is strong enough without using deck guard post brackets. The middle image depicts a deck guard post properly attached with brackets. So again, this maintains, so the load is all transferred. So if you were to push on the top of this rail, everything according to the band joist and the floor, or the deck joist, that would all be supporting this post now. Versus in this situation on the top right hand side, the post is only as strong as this connection, or as the wood is from the cut to the face of the post. Most codes require guard only around decks of 30 inches or higher. Why would a home inspector recommend guards for a lower deck, even when the recommendation exceeds code requirements? The primary reason centers on safety and liability. While the building code establishes minimum requirements of 30 inches, a professional home inspector's role goes beyond just code compliance to focus on overall safety and risk mitigation. Fall injuries can occur even at lower heights. Home inspectors often make recommendations based on best practices rather than just the minimum code requirements. Guard height and openings. Ladder type guard infill on high decks is prohibited by some local codes because they're easy for children to climb over. It is very common, these cable railings are extremely common, and they're building them like crazy on new construction. So it's almost every time I call out, it's a comment that I have as a default in my report stating, although intended and installed for aesthetic reasons, horizontal balusters or horizontal spindles are not recommended, or horizontal cables are not recommended, because it allows a child to potentially climb over. And then over here, the balusters or spindle spacing, infill should not permit a 4-inch sphere to pass through. And then, honestly, something that I learned when I went through this class is, making sure you angle cut. Now, this would be a recommendation. There's no requirement for this anywhere, but it is good that if you have an opportunity to have a say in how the deck is being built, that you recommend that either waterproof caps or the angle cuts be put on these balusters or these spindles to deter water from sitting on the top of a flat surface, because you have the end grain of that wood, and end grain of wood was intended to soak in. I mean, that's how a tree operates, right? So so if you leave those flat and rain sits on there or moisture sits on there for any period of time, the wood naturally wants to pull it into itself, and then you get dry rot, and then the tops of the posts are rotted out. We have how close to 4 inches do you comment on? I have seen 4 3/8. I called it out as regular comment, but not as a defect. Yeah, I think anything above, anything wider than 4 inches, I would just automatically call it out. It's totally up to you and how you like to portray your inspections for your clients. If you want to make a big deal about it, that's totally up to you. But it, technically does not meet minimum standard. So again, code is minimum standard. If you wanted those balusters, those spindles closer, definitely recommend it. But again, it's a lot of times it comes down to how the homeowner, do they like that aesthetic? Do they want that aesthetic? And as long as you warn them about the what could happen because it's outside of standard, it's up to them, it's up to the client on what they do with your information. So totally up to you on how how important you want to make it in your report, but as long as it's in there, you're covered. But how big of a deal you want to make it, or how big of a deal that the homeowner wants to make it to the seller or to the builder, that's totally up to them. Board placement and support. So wood decking should be attached to each supporting member or each supporting joist with at least 2 8D threaded nails or 2 8D wood screws. Or I'm sorry, 2 number 8 wood screws. The ends of deck boards near the chimney or bay window can extend unsupported up to 6 inches. Basically, if you're coming around and you have a deck going around a chimney area, and you step on this area at all, I mean, if you don't want to take an exact measurement, for me, I guess you do want to inspect from the bottom up. So you should be able to see this span and tell how deep it is. But also, when you're walking on the deck, I like to walk in this area also to see, is there a sag? Does it move? And if it does at all, I recommend it to be secured up, because the last thing you want is, that to move a little bit, and then you get off balance, and then you could potentially fall, or the customer could fall, or one of their guests could fall if they're having a big deck party, and there's tons of people standing in that area. You want to make sure that your deck is going to support all those people and support and then not deteriorate or damage during that event. So decking should have an 1/8 inch gap between the boards so that puddles don't form. Here, I'm going to read through this. So we're going to come back to that. So decking should be staggered so that the butt joints don't land on the same joist side by side. Each segment of decking should bear on the minimum of 4 joists. Inspectors should look for splitting in the decking and nail pullout. Aside from structural issues, nails that have been pulled out or lifted out, or screws that are not driven into the decking fully, can cause injury to bare feet. So the 1/8 inch gap between the boards, if it's a manufactured deck floor material, so they're going to have different standards than your standard wood flooring. So just keep in mind that if you have a manufactured deck floor, that you refer to the installation instructions as far as spacing goes. But if you're just with standard wood, you want to make sure that gap is there, because what can happen is tree debris or plant debris or whatever. If there's not that gap there, it will fill in these grooves, and then it holds moisture against that wood, and then it'll prematurely rot and deteriorate. A lot of times the old rule of thumb was, well, I know deck builders in the past, they would purposefully butt all of the deck boards together, because as they cured and dried, they would then they would have that 1/8 inch gap there. But you can't count on that. So if you have a new deck and they're butted directly against each other, I would definitely call out that that spacing should be separated. Again, that deck contractor is going to come back and they're going to say, oh, well, when the deck cures or it dries out, then it's going to shrink, and then you'll have that gap there. But I've seen deck boards that gap never came to fruition, and so they had a lot of water damage going on that deck. And so from the installation, I like to see that that gap in between the deck boards. And then you definitely want to make sure that your deck boards are spanning more than 3 joists. You want to make sure all your mounting hardware is there. You want to make sure that all of your joints don't fall in the same path. Everything is staggered. And another video. All right, here we go.
I'm Ben from InterNACHI, and I'm standing in front of the InterNACHI House of Horrors in Colorado. It's an entire house with 1,000 defects built under our roof. In this video, we're going to learn a little bit about deck ledger flashing, and we're also going to refer to the International Residential Code. So get out your textbook and let's take a look at this demonstration of deck ledger flashing. Okay, so the International Residential Code, love this code book. It's the 2008 section R703.4, flashing. It says approved corrosion resistant flashing shall be applied in a shingle fashion in a manner to prevent entry of water into the wall cavity or penetration of water into the building structural framing components. And self-adhered membranes could be considered flashing according to some standards. So that's again R703.4. So let's go over some of the components of this little demo here of the deck ledger flashing, and then we'll talk about the flashing itself. So this is the poured concrete foundation on some grass next to it, and there's a seal gasket, seal plate on top of the foundation wall, band joist, floor sheathing, stud wall, exterior sheathing, and this is the house wrap. And this is also considered the drainage plane and the water resistive barrier. This is flashing here. So this would be installed next. This would be below the ledger board, and the membrane would be installed this way on top of the top edge of the flashing, and then the ledger board is installed. So the top edge of this metal flashing down here would be protected by a shingle manner like installation of the membrane waterproofing. And then the ledger board is attached. It's got to be at least a 2x8. And then flashing on the top. And then to cover that top edge of the metal flashing, we have the membrane once again. It's adhesive, right? Now, to stop, to continue that shingle flashing manner, what we did was we cut the house wrap and feathered in this top membrane, which is covering the top of the metal flashing. And it's adhered underneath the house wrap. And then this incision, this cut, is taped over. So this is flashing, metal flashing, metal flashing. You've got your floor joists attached with floor joist hangers to the ledger board. So in the code book, it says applied in a shingle-like fashion, right? A manner to prevent entry of water into the wall cavity. Well, I think of shingle-like as to be like this, where we're referring to asphalt shingles of a roof, and the bottom layer is there, and then this is shingled on top of that and shingled on top of that. So everything is diverted away. It's shingled, it's overlapped in the correct manner. There isn't any open edge, right, to allow water to come in. Everything, if you can imagine water coming down in a shingle-like fashion, everything's installed in a manner to divert water away from the structure itself. So when you're looking at the installation of deck ledger flashing, the important part is it's installed in a shingle-like fashion. So let's look at this a little bit up close. Again, the metal flashing overlapped with the membrane. The deck ledger is attached. And then at the top, let's remove the floorboards of the deck. We have metal flashing here. The top edge of the metal flashing is overlapped by another sheet of membrane, and then that incision where it's feathered in and taped over. Now, the actual installation of all this shingling and materials isn't detailed in code at all. It's really construction standard best practices, things like that. The code just says applied shingle fashion in a manner to divert water away. So there are a few resources where you may see some differences in between this area here in particular above the top flashing, but the idea is to shed water away. Another detail is how does this flashing, how do we get this installed properly? And there are many recommendations. Code is silent. Some resources say that the contractor should make some incisions on both sides of the floor joist and bend this down. Some say that this flashing actually should be installed behind the ledger board. That doesn't make any sense. Another one says it should be lipped over, and that would mean bending the flashing on site. I think cutting the flashing and bending the flashing is too much. It introduces too much room for human error with the contractors. This is actually very easy to install. and you would actually pull the floorboard away just a little bit to give it a little room to drain. Code mentions water resistive barrier, and it says the water resistive barrier in section R 703.2. It's one layer of number 15 asphalt, felt, complying with a certain standard, or other approved water resistive barriers, and that's the waterproofing membrane. So this material is compliant with code and best practices as well. There are a bunch of defects that you probably see. The fasteners aren't installed properly, and the actual joist hangers were cut. They were actually for 2x10s, and this is a 2x8 installation. Now, one of the things while we're here is clearance to grade. If siding was here, let's just assume siding is here, it would be installed below the bottom flashing. And you can think of 2, 6, and 8. What you want is 8 inches from this piece of wood. Any wood seal component on top of the foundation needs to be at least 8 inches away from ground, unless it's preservative treated. But in general, I think of it as a home inspector, 8 inches. If there was siding here, the bottom of this siding should be at least 6 inches from grade. And if the ground was a walking surface, like a sidewalk, a hard surface, you need at least 2 inches of clearance. IRC code book says section R 317.3.1 talks about the fasteners. And then we talk about also 1/2-inch diameter bolts if the fasteners of a ledger board is for bolts. But the fasteners here includes nuts and washers for preservative treated wood, shall be of hot dipped G185 zinc coated galvanized steel, stainless steel, silicone bronze, or copper fasteners. Here we have fasteners attaching the ledger board to the structure. Here, there's one there, there's one hidden over there, and they're actually, we picked these up at Home Depot, ledger lock. And ledger lock actually says the coating on this fastener has been tested in wood treatment chemicals such as ACQ and found to provide equivalent protection to code approved hot dipped galvanized. So they're saying it's equivalent to the code requirements. And obviously there's a defect here. This isn't sunk in all the way, and this is sunk in too much. And that one is actually behind the joist, which isn't a problem, except for the joist now is not fully inserted into the joist hanger. The ledger board has to have a clearance of 2 inches. So you can't have a fastener within the top 2 inches of the ledger board and the bottom 3/4 of the ledger board. If it's too close to the edge, the idea is that the board will crack. So the top needs more meat of the wood. So there's a 2-inch clearance. Can't have a ledger fastener within that top 2 inches and the bottom 3/4. This one here is getting a little close. So it's one of the things you can keep a look at. Oh, and also 2 inches from the end. So if this was an end of a ledger board, you don't want a fastener at the very end, it would crack it. And code mentions the seal gasket, and it's in section or table N1102.4.1.1, and it's really for air leakage. There are termite plates and things like that, but air leakage is recommended to stop air leakage. There's also recommendations from other sources about putting spray foam sealant or glue here, 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 and there, just to stop air leakage. Now let's take a look around the other side here, and we can take a look at bolts that attach the ledger plate, that attach the sill plate to the poured concrete foundation. 1/2-inch bolts need to be embedded into the poured concrete foundation at least 7 inches. It's impossible for a home inspector to see that. You can look for defects like a loose washer here. You can look for spacing as well of the fasteners, and you want the fasteners within the middle third, ideally. You don't want, again, a fastener on the very edge. You can also take a look at the ledger board fasteners as they come through the band joist. the tips are required to go through the band joist. And I see one here, so that's good. There's a crack in the floor joist here. Looks like a nail was missed there. So that's a quick training video on the deck ledger flashing. Remember, a shingle-like manner. And this demonstration is always here at the InterNACHI House of Horrors in Boulder, Colorado. Feel free to come on by and take a look for more defects. And I'll see you in the next video. Bye.
All right. And now we're back. So handrails. Stairs with 4 or more risers should have a handrail on at least one side. Handrail height should be between 34 and 38 inches measured vertically from the sloped plane adjoining the tread nosing. Many deck handrails improperly consist of 2x6 lumber or decking. Handrails should be graspable, continuous, and smooth. I really like this this bottom right diagram. It shows where the handrail does not return back to the post to the support post. When I was in elementary school, we were in our at the stage area, and I don't know what we were doing, preparing for something. Anyway, so one of my classmates, I think that was in the grade was I in fourth grade. Anyway, so the handrail extended out past the stairs, and so the teacher told us to get up, and my friend, he stood up and he turned around, and he was, we were fourth grade, so he started to run to the front of the class to be the line leader or whatever. And when he turned, that post stuck him right below his chest bone, or right below his sternum, and it actually penetrated, and it ended up doing internal damage to him, which is the whole reason why posts now have to be returned to or turned back into the support post. So keep that in mind. Where now in this situation it would be hard for anybody to run into the end of this, but especially if you have a handrail that extends out past its support post, those definitely should be called out as a safety hazard. And then you're going to find this situation is going to be very common, where you have the 2x6 top, is used as the handrail. But again, it's not graspable. A lot of times as the wood ages and deteriorates, you're going to get splinters, coming up off the top of this. So it's always best to just recommend an actual handrail be installed. Gentlemen, those of you guys that ask questions, I will refer to them here when we have our next break in about, here shortly. Here's some more examples of graspable handrails. So the 3 images above depict graspable handrails. Many deck handrails improperly consist of a 2x6 inch lumber or decking. Again, handrails should be graspable, continuous, and smooth. And that, that's for people walking up or coming down the stairs, so that if your foot hits, the stair tread, and then you immediately want to go and grab for something so that you don't fall on the stairs. And then same thing coming down. What's very common, especially in my area, we don't get ice very often, but when we do get ice, it tends to stick around for 3 or 4 days, and people stay home from work, stay home from school. Everybody goes and has a good time at home. But those deck stairs, those treads, have ice on them. And so you're not used to that, as you guys are in New York, and you're going down the stairs and you're excited, and your feet slip off, and immediately your hands go out to the side, and you want that handrail to grasp onto, so to keep you from sliding all the way down or hurting yourself, so on and so forth. So yeah, we are at break time. So let's take another 10-minute break, and we will be back here at 7 o'clock my time, 7 o'clock Central. So Adam and Brandon, I'm going to answer your question. So the strong drive structural wood screws can be used to fasten the ledger board to the home, can't they? I would imagine so. I would have to, that's where you should, pull up the installation instructions of the product, or the technical data sheet, and read, what exact they might be allowed, but there might be limitations on how many, or they might require more of those screws to be installed. If they are allowed to be installed, there might, again, they might require more screws to be installed. So I'm not 100% sure on that exact make and model, but I would just encourage you to go and read all about it, read all the installation instructions, and see what kind of limitations. If it's a one for one, then yeah, all you have to do is comply with the spacing and all the requirements that we've mentioned already. But again, you might have other requirements that that specific product has to use in order to meet the minimum standard. And then Brandon, I never see Z flashing on new deck builds. Yeah, it's I definitely never see it on the bottom part. I do see it on the top part, but again, you go back to uh, you go back to you definitely call it out. You provide the information, you let the client deal with it. However, kind of like in my situation where I called it out, they came back, they said the deck was covered, and that it didn't require Z flashing, and then they pulled out the whole, well, the code inspector didn't call it out, so I don't have to do it type situation. So as long as you explain, to the client, hey, this, you're missing this might happen because this is missing, definitely recommend it to be updated. So in that specific instance, that deck ledger was in between the basement, the walkout basement, and the first floor. And so there was a ceiling, and so there was no way to verify the interior portion of that deck attachment, and and how the deck was attached, and all that, all those items too. Um, uh, but their explanation, I at least told them, okay, well, if you can't get the whole ledger flashed, then you need to at least flash the ends, because when the rain blows in and you have that penetration into the siding of the home, that is a very susceptible area on the ends of those ledger flashing where the rain can blow in from both sides. So I can see how, now I would always install the flashing, but I can see how you might not need ledger flashing for the interior middle part of that deck ledger, because it would take, it would have to be a lot of water over over a long period of time for that water to get in and cause damage. But they needed to at least flash the ends. But like I said, they hired their own contractor. All they did is they took up that first floorboard, and feather the flashing in, and then put it back down, and it was, so I don't know why the contractor made a big deal about it, because you're protecting that client, you're protecting the structure, but contractors, they just sometimes they do what they want, depending on a lot of times, like, there's no ramifications for them to not do it in that instance. And so what is very common in my area is, if you don't like it, you don't have to buy it, because the next person will come in and buy it. So a lot that gives them the confidence to be able to say, well, I don't have to do, I don't have to do it to minimum code, because somebody won't get an inspection and they'll take care of it, and I'm not, I don't have to worry about it, because more than likely you're not going to have moisture damage for that first year builder's warranty that is required in my state. So uh, just keep all that in mind when you're making your reports and your evaluations, and just make sure you're taking care of your clients. William, I have seen contractors cover pressure treated wood with roll flashing and use aluminum trim coil. Yeah, 100%. Um, yeah, aluminum, and like, it looks good. It looks good when it's first installed. It looks like it should, do the trick, but it degrades so quickly that it's basically non-existent after a few years. Um, And what we're seeing a lot now is contractors are using zip tape for dang near everything. So where metal flashing was used in the majority of areas for for all the penetrations, now it's zip tape flashing is used for everything. And a lot of times, technically, the zip tape flashing, the self-adhered flashing, does meet those standards. But you'll see some like I said, some pictures here at the end where they didn't use any flashing, and then or they didn't use any, which didn't make any sense. They didn't use any flashing on the ledger, but then they flashed the tops of all the joists before they put the deck boards down. So, like, well, that's great that you guys that you put the zip tape flashing along the top of the joist so they don't rot, but they didn't protect the connection to the house at all. Do you require joist tape in most areas? So if you're talking about the joist tape that goes across the top, I would recommend it for every deck, but there is no requirement for that. Now, sometimes if you have a manufactured deck system, then the installation instructions will specifically call out joist tape. But on your standard, your standard deck, there is nothing in the code that recommends or requires it to be. I don't even think it mentions it for taping across the top. But as a best practice and for the longevity of the deck, I would definitely recommend it for the client. Back to handrails, guardrails. Open risers should not allow the passage of a sphere 4 inches in diameter. On stairs with a total rise of 30 inches or less, the size of the open riser is not limited. Horizontal guards at raised floor areas, balconies, and porches should have intermediate rails or ornamental enclosures that do not allow passage of a 4-inch diameter sphere. The triangular area formed by a tread in the riser, so this guy right here. Hide this. So this guy here. The triangular area formed by the tread, riser, and the guard should not allow a passage of a 6-inch sphere. The opening at guards and on the sides of the stair tread should not allow the passage of a sphere of 4 3/8 inch in diameter. And then I don't believe we have any Canada contractors, so we'll leave Canada out. And then the maximum 5 feet of maximum between newel posts. So, and a lot of times, I think it's 6-inch maximum for stringer length. So if you have longer than 6 feet of a stringer, then you should have support, vertical support underneath, some type of extra support. Electrical requirements or receptacle requirements. So the receptacle shall be located not more than 6 feet and 6 inches above the balcony, deck, or porch surface. Any dwelling unit with direct access to the ground level must have an outdoor receptacle at both the front and the back of the house. A receptacle that is part of a yard light on a post, for instance, does not meet the requirement. If the dwelling has a balcony or deck accessible only through a door from the inside, an outdoor receptacle located on the balcony or deck may not fulfill the requirement if it cannot be accessed from the ground level. However, if the receptacle is within 6.5 feet from the ground and can be reached while standing on the ground, it can be counted as the required receptacle. To protect people, GFCI protection must be installed at all 125 through 250 volt receptacles installed outdoors and supplied by single-phase branch circuits rated for 150 volts or less to ground must have GFCI protection. All exterior receptacles should be GFCI protected. There's only one exception for outdoor receptacles not readily accessible for snow melting or de-icing, but installing all GFCI protected receptacles is strongly recommended. In addition, those receptacles should be weatherproof. So in damp or wet location, boxes, conduit bodies, and fittings should be located or equipped to prevent moisture from entering the box. Conduit body or fitting, the box cover should be installed with a gasket to prevent moisture intrusion. Receptacles installed in damp locations and protected from the weather, like under a roofed open porch or located in other damp locations, must have an enclosure that is weatherproof or weather tight. Then when the receptacle cover is closed and an attachment plug is not inserted. A receptacle installed in a wet location exposed to the weather must have an enclosure that is weatherproof, whether or not an attachment plug is inserted. So you have to have that bubble, that bubble enclosure in that location. These receptacle covers provide sealed weather protection even when cords are plugged into the receptacle. Service drop clearances. An overhead electrical service conductor that is connected to the house must be at least 3 feet horizontally from the edge of the deck. When overhead electrical service conductors are within 3 feet horizontally from the edge of a deck, they must be at least 10 feet above the walking surface of the deck. Sometimes the inspector will inspect a new house and the service cable may meet code on that day by being 12 feet above the backyard, but then later a new deck will be built under that cable and the clearance is reduced to hazardous inadequate height.
The way I start is from the bottom up, just the way it was constructed. So I'm gonna get underneath the deck and take a look at the deck structure from underneath and work my way up. Let's go. All right, so I'm under the deck on the ground floor and I'm taking a look at the structure. I can't see the footings because they're buried underground, but the posts are huge. They're masonry. I'm gonna take a look at the floor joists above me, 2x8s. I'm gonna look for notches or cuts or damage. I'm gonna see how they're attached to the band rim joist, outer edge of the deck. That's resting on the posts. The beam is resting on the posts. I'm gonna take a look at the span of the floor joists. I'm gonna take a look to see how the joists are attached to the ledger board. I'm gonna take a look at the ledger board, see how that's attached to the house structure, and look for flashing. All right, let's do it. So again, these posts, masonry, can't see the footings. No way. I'm not responsible for anything that's buried. Can't see it, can't report upon it. And then the beam above is supported by the masonry posts and the floor joists resting on a 2x2 ledger board. And it's fastened with 3 nails right underneath each floor joist that rests on the beam. And I see the stringers of the stairs, and the stairs are resting a piece of pressure treated wood. This is all PT pressure treated wood that I see. So that's good. So this is the beam structure. It's 2x10s resting fully on the post. So that's great. And a 2x2 ledger. And the joists are hanging, resting upon this ledger. And they span across this distance and attached to the ledger board of the house. This is really great. I see a lot of bolts, almost in every bay. Now I'm going to take a look for trip hazards as you approach the deck. There's a sidewalk, a landing, a few steps with a handrail, and the walk into the entry. And I don't see any trip hazards. It's a good way to just inspect it by walking it. And then the floor joists and the floorboards, they're in pretty good shape. With some of the fasteners coming up a little bit. But it's pretty minor. Now the handrails and guards. Technically, this handrail isn't grippable. You want a handrail to be a graspable thing. So it's non-standard. You want to measure or check, don't have to measure if you're a home inspector. The height of the guard is a guard from the top to the floor surface and the space between the spindles of the guard. You don't want it to be large enough for a child to fall through. And then you can take measurements on the guard on the stairs as well. You don't want large openings. And on a guard, you want to be able to push it down and out with a load. So this is strong and out is strong. It used to be in any direction. So this feels good. This feels good. I'll just go around and do a random grab and push of the spindles. So that looks good. Now, if I wanted to take some measurements of the open spaces and the height of the rail and the steps and treads and things like that, I can do that as well. I'll do it with my aft. And where the deck meets the house wall, I want to make sure that there's some kind of flashing. It looks like there is. The very bottom of this siding material, there's a piece of flashing here. But again, I really can't see anything. I can't report upon things that I can't see very well. And I'm also looking for wood rot on the load bearing components, on any component really. And you can use a screwdriver and listen. And the front deck has a GFCI with a weather cover on it, and I'll test it with my GFCI tester. Good. Okay, we're on the second floor deck, and my inspection is limited because the floor structure is covered up. From underneath, I couldn't see anything, and here, it's a bit limited, and above me, all of this is finished really well, so I can't really see the structure above, the roof structure. So I'll just report upon things that I observe. Looking for wood rot, looking for space between the spindles, looking at the floor condition, the floorboards, and the flashing, and the height of the guard. And I'll give it a little push down and out. And up here, it looks in pretty good shape. I don't see any indications of major defects while inspecting the deck from the underground, from the first floor, and from the upper deck. There's also a deck on the rear of the house, small deck. So I'll take a look using the same procedures, starting from underneath. And what I noticed though, while walking the stairs, is that this step at the very top is different from the rest. And this bottom step is very high. So this one is very high. And this one's very short. I'll take a measurement of each, but that's a bit of a trip hazard. And then as I was walking around, I noticed we have a little bit of plant growth. So there's some moisture and probably some wood rot, and those little guys love to grow where it's wet and rotten. And also the space between the spindles, I can eye it up. This is going to be a little bit too big. But I'll take a look at the height of the guard as well. And I can't get underneath the deck. So this is a little crawl space area accessible from inside. The stairs are resting, the stringers are resting on concrete. That's good. But that first step is a little high. And I see a GFCI outlet in the back, accessible from the deck. And there isn't a second floor deck, there's the house there. So a couple things on this back deck. So at that wood rot area, I'll take a look at the underside of the deck. And under the deck, I'm not sure why they did this, but there's plastic under the floorboards. And it's holding moisture. So that's why we have some wood rot here, possibly, and some other deteriorated wood here. I don't think they need that plastic. Right, that was a deck inspection. Hope you enjoyed it. We found some defects.
All right. Get back to here. All right, decks should not be located where they might obstruct septic tank access, underground fuel storage tanks, well heads, or buried power lines. The right image depicts a deck obstructing a basement bedroom's emergency egress window. The path of egress should not be obstructed by infill or lattice. Basements, habitable attics, and every sleeping room must have at least one operable emergency escape and rescue opening. Where basements contain at least one sleeping room, an emergency escape and rescue opening is required in each sleeping room. Emergency escape and rescue openings installed under decks, porches, and cantilevers must be fully openable and provide a path of at least 36 inches in height and 36 inches in width to a yard or court. A deck at the required egress door must not be more than 1.5 inches lower than the top of the threshold. It is common for a deck to be attached to a rear of a house and at a non-egress exterior door. As long as the non-egress exterior door swings open to the inside, the deck outside the door can be up to 7.75 inches below the top of the door's threshold. Dropping the deck down a step from the exterior door works well because that provides space for a properly installed seal between the door and the exterior wall covering. The drop down step also provides space above the ledger or flashing behind the exterior wall covering, or above the ledger for flashing behind the exterior wall covering. But dropping the deck down a step may make it difficult to securely line up the deck ledger with the house floor framing to create a secure lateral attachment. Very common. I see this a lot in my area where decks are often built over septic tanks. I've seen a concrete pad poured over a septic tank before and they put a hot tub on top of it. And then the deck was on top of that. So, we're definitely not septic inspectors, or you don't have to be, but if you see the tank or you see the lid and it's below the deck, then I call that out all the time. And then for sure on the egress being blocked, from decorative lattice and things like that. Exhaust clearance. So combustion air intake openings located on the exterior of a house must have the lowest portion of the opening located at least 12 inches vertically from the adjoining finished ground level, deck floor surface, or deck structure. Combustion air can come from underneath the deck. It just can't be obstructed. Category 4 high efficiency appliances such as furnaces and water heaters may have vents that are only for exhaust, or they can include a combustion air intake with either a concentric termination or a pair of pipes. These vents must be installed in accordance with the manufacturer's installation instructions. The vents must not be blocked or obstructed by the deck floor, deck components, or deck structure. Exhaust ducts must terminate outside of the house. As a general rule, the exhaust duct should terminate at least 3 feet in any direction from the openings into the house. The clothes dryer exhaust must terminate outside the house. The clothes dryer exhaust sometimes terminates through the band joist and at the same location as the deck ledger board connection. The clothes dryer exhaust vent hood must not be blocked or obstructed by the deck floor, deck components, or deck structure, and it must have adequate clearance from the deck. Obstructing a clothes dryer exhaust is a defect and can cause a fire. Weep screeds and holes, masonry, stucco, eaves, and other cementatious type claddings are not waterproof. Moisture that gets through or that condenses behind the exterior wall covering must be designed to drain through openings at the bottom of the walls. Deck ledger boards must not block the drainage openings. Weep holes for anchored veneers can be made of corrugated plastic, a tube, a wick, or by not grouting the head joint. These drainage openings are permitted to drain onto the deck or below the deck, but not into the back of the deck ledger board, floor joist, or beam. All right. Let's see. Perfect. We're doing great on time. So I have a lot of pictures. I have 2 reports that I can pull up. So just a little bit of background. I do litigation inspections. And so for somebody, for a homeowner that is unhappy with their contractor, I think we call them expert witness, but I don't like to call them expert witness. I like to call it, um, uh, customer advocacy is how I sell that service. Anyway, so I have 2 reports, and then these are 3 pictures, but I have 2 reports after this where I was called out for customers that were unhappy with the contractor's deck construction, and a lot of times it never even got through full construction. It went half of the way or 3/4 of the way, and then they just kept having all these red flags, and they were not getting positive responses from the contractor, and so stop work orders were put in, and then by the client, usually not by the code official, but by the client. And then I get called in to come in and provide documentation for them to be able to get some type of resolution. So this specific picture and the report that I'll show you that is in conjunction with these, this was a $40,000 deck. It's on top of a mountain, was overlooking a river, beautiful piece of land. And unfortunately, in Missouri has no licensing laws. If you're so they have no code requirements and no licensing laws unless you're within city limits of a town, and then it's up to the city on how they deal with licensing and code recommendations. So, unfortunately, this house was outside of city limits, and the homeowner trusted his a coworker of his, and and a lot of times what I end up seeing in these situations is where the GC might know, what they're doing, but they just don't oversee the project. And so a lot of times the general contractor, the GC, might know what they're talking about, but then they send out contractors who are not versed or not good at their jobs, or have never read a code book or never read installation instructions of their products. And so that's kind of the situation that we got into here. There was just no oversight on this job at all, and it was like I said, it's in a state and an area where there was no requirements for contractors for any type of knowledge. And so on this left picture, again, so I got about 3/4 of the way through, and then and was unhappy, and so they stopped work order. So they never actually ended up putting up the handrails. They got some of the posts going on, but in this picture alone, on the left-hand side, I can't tell, like, almost everything in this picture is incorrect. So they use 4x4 support posts. They did notch them, so it's notched on the inside here. They did not use through bolts. They did not use lag bolts. The handrails, definitely missing, but that was not under construction yet. The footers, if there were footers, they were not, if they had installed footers, they were not the correct sizes and they're not correct depths. And you'll see some pictures later on. So again, so in this, and you'll see later on, but there is no ledger flashing across this whole ledger. The posts are wrong. There was a lot of stuff going on here. So this picture in the middle again. So they used the wrong. They cut the joist too short. They tried to make it work, but again, this is completely out of installation instruction requirements for strong tie, Simpson strong tie, and their requirements. And then this is the great example of why you don't use 4x4 posts in for your guardrails. Even though they have some blocking that they attach to here, one push on that board and it broke that deck post, support post right at that angle right there. Let me see. Let me go over here. So let's see. Is this the one? Yeah. So this is that same house. So this manufacturer, which I cannot remember what the product was. I think I have it later here in the report. But so this is a screenshot from the installation instructions where it required, because of how the deck boards are manufactured, they're or the floorboards are manufactured, it requires no more than 16-inch on center for supports. And so you can read that in the installation instructions, and then you come down here and we're at 17.5 on this joist, that joist span, another 17.25 on that joist span. This one's another 17-ish. Again, so just so because this is a manufactured product and this comes from anything that is outside of the manufacturer's installation requirements has now voided the manufacturer's warranty. So if it comes out that the manufacturer had a bad run of that product and was just not, it was not, it didn't adhere correctly, or all the material did not meld together correctly, and they had a recall on that because you were walking on the deck and the deck boards just started breaking or cracking, then if they had they lost that opportunity to make that manufacturer's warranty claim because the joist spacing is incorrect. So unfortunately, this client, because they're outside of city limits, and there's no requirements for the contractors, the only thing that we could hold them to, the only thing that he could use in court was the installation instructions for the manufactured product. So that his lawyer, the only thing his lawyer could use in court was the installation instructions of the manufactured products. It wasn't to the IRC, it wasn't to any standards. There's nothing to hold them to except the installation instructions. So because they had a lot of issues and the overspan, so they just added all this blocking. And so the homeowner actually took up all the boards that were installed here because he was unhappy with the installation, and he wanted to show me everything that he was seeing. So in this picture, you can see there's no ledger flashing. They installed these horizontal blocking, but then they didn't use joist tape to seal it up. And so then, water would penetrate through here. It would sit on that horizontal surface, and this would all rot as one. I was hoping that there was. Oh yeah, so here, so this is TimberTech Pro. TimberTech Pro installation instructions do require joist tape installation. So while we couldn't find it on the Trex, TimberTech does require. So that's what we were showing here. That and the fact that because this is technically part of the joist now, they would have had to joist tape this whole section in order to comply with the installation instructions. Let's see. So you can read my comments here. Per the manufacturer's installation instructions, the deck ledger is intended to have visible flashing. So even though, there is code, so in this instance, because we couldn't apply, we couldn't use code to the benefit of the client, because it would have been thrown out in court, we had to use the installation instructions, which luckily does call out that you have to install ledger flashing. And so you can see that here in this arrow. So there should be a drip cap, flashing, or other system in place at the ledger board wherever framing meets the home to move water away from the home and away from the deck. I told you I love this diagram. Hardy plank siding on the house, yes, and it is also completely installed incorrectly, which was another part of the claim. So there's a lot going on this house. So they opened up doors and windows, but never put headers up above them. So there's all kinds of issues going on with that too. But yes, so they're missing all kinds of stuff when it comes to the wall cladding, to the openings in the house, all that good stuff. So, so mounting hardware. So mounting hardware is lacking on the deck joist hangers. For the hangers to provide the intended support, all mounting holes should be filled with corresponding mounting hardware. Joist hangers having been modified and or not installed per the manufacturer's recommendations. follow the link for more information. And I like to include, so just like hardy plank, if I write a report and it shows the defects of the hardy plank, I screenshot and include the installation instructions into my reports. Now, you don't have to do that. You're not required to do that. Like I said, I do a lot of litigation, so I do provide those things. But so this is Simpson Strong Ties installation requirements for their joist hangers, and so basically this is what I'm showing here, and that's where this picture comes into that's where that picture comes from. And then again, where they modified these joist hangers, mainly so that they could make the joist level with the band. So they modified that. Again, all of this is outside of manufacturer's installation instructions. Missing mounting hardwares, all over. More missing mounting hardwares or hardware locations. If you didn't know, so this little tab that you can kind of see, which I can show you on this one. So these little tabs, I'm blocking them. So that tab right there, those tabs are just for the contractor to be able to push that into the wood so that then they can make the connections into the mounting holes. So just so you know, if you weren't familiar with what that tab is for, that's what it's. All right, and so this is where, we're getting into the mounting hardware, the deck ledger mounting, and all the flashings, the configuration of the bolts, and how it's all missing. 6x6 notching of the posts, and then the footers. So here you're going to see, again, the ledgers was attached with nails. I think they just used their standard 8D nails that they had in their nail gun and attached the ledger board to the house. Incorrect. Overnotched safety railing posts. You can physically see the sag in this beam because it's not supported correctly. Beams that are not supported underneath the splices. Again, 4x4 notched posts. Splices in the beams that are unsupported, that they tried to add some blocking, some weird, like they really had no idea how to frame up a deck. All of these, so you have these precast concrete supports that were not, they're just sitting on top of the ground. There's no footer. Everything's just sitting on top of the ground. I think they did bury some of these supports, but no footers, no concrete, no gravel, no nothing. And like they were saying over here, there's no supports underneath the stringer. This support post for the stringer is just sitting on top of the ground. Because there was a lot of lacking support posts, the joists were overspanned in areas. Then we were starting to get horizontal cracking through the joists. You can see one here, and then this whole span here was cracking because one, there's no footers. There was all this, everything was overspanned. Just like all around, just I felt so bad for this client. And then we're getting into other things that are not deck related. All right, and then so that was kind of that report. Here's another report. I just did this one recently. Kind of the same situation. Client was just seeing all these red flags. They called me in and are trying to get resolution. No, they framed around that tree, but they did it very poorly. Again, so you know what? Let me go back to that tree. Yeah, so when the deck boards, I didn't take, you can't see it in this picture, but the deck boards overextend around that tree. So they took the deck boards all the way up to the tree and just left a little bit of expansion contraction room, but it was over the 6-inch or the 6-inch maximum span for the deck, for the manufactured deck boards. Okay, here. All right, so just right off the bat, they did use 6x6 posts, but the footers that they poured were 4-inch 4-inch concrete pours. And so technically, if you were to do it gets a lot more detailed if you actually read the code, but by the rule of thumb we use is the 3-inch, or the deck post times 3 is how big your footer should be. So on a 6x6 post, you're looking at, you should have had an 18-inch footer on that guy instead of 18-inch concrete pour on that instead of what was that, the 8-inch? Yeah, 8-inch, I think that is. So I think it's here, down here in the report. I use home gauge, so you guys might notice some of this stuff up a home gauge, but here that is. So here's the support post span table. And so where it's showing that for that specific, this specific location, it should have been 21 inches. So like I said, I just generally use that rule of thumb. I'd said 18 inches. And if you were to actually go by the span table, then it would be, or by the appropriate table, not the span table, but the table indicated here, it would have been 21 inches. And then here's just a good diagram of what footers should look like. So we have a 10-inch. Okay, so it was a 10-inch footer. So we were about half undersized from 21 to 10. And then you can also, well, there's a better diagram of how deep the pour went. But let's see. And again, so here's where the deck joist, I'm just going to read this. Deck joist hanger fasteners are mixed hardware, are using mixed hardware where some are rated for structural connection and some are not. Simpson Strong Tie LUS model joist hangers states that only approved fasteners should be used and that are of a specific material, size, length, coating, and structural capacity. Most of the LUS joist hangers installed on the ledger board have green T25 star head screws installed. Per the manufacturer's website, these countersink screws are intended to attach the deck floorboards to the deck joist and other non-structural related mounting. The Grip Right Deck Force website technical data sheet does not give a shear rating needed to use as a structural fastener. So if you are going to use, if a contractor is going to use screws and nails or whatever as fasteners that have the potential for to have can have shear, then they have to have shear rating in order to be considered a structural fastener. And then here's my disclaimer. We did not remove screws to determine the specific model installed and only reference Simpson Strong Tie model installation instructions and the screw containers with corresponding technical installation data sheets. So I had to use the boxes and the stuff that I found on site and then matched it up to what was installed on the material itself. And again, take pictures of the models, make sure you're looking up the correct, the correct model with the correct installation instructions, because Simpson Strong Tie has a massive amount of inventory when it comes to hardware. And so make sure that you're pulling up the right data sheets, the right installation instructions, and applying it correctly to your situation. Here again, it just points out the nails that if they're going to use nails, the nails that should have been used, so on and so forth. So minimum 3-inch nail recommended in the LUS joist hanger model. And again, let's see, I think so 3-inch on that one, and then this one is a 2-inch. I think that's why I matched these up. So this one was 2-inch, and then this is what they used in the joist hanger. So they used a 2-inch instead of a 3-inch, and they use exterior wood screws instead of structural screws. So again, falling back to the Simpson Strong Tie, joist nails must be driven at an angle through the joist or truss and into the header to achieve the table load. So this is a great diagram. You'll find this a lot when they use nails that are not approved or not long enough, and it doesn't provide that crossover for that structural support. So if you find Now you won't be able to see this, but if you see nails on the ground or you see a box on the ground, especially new construction, then you can kind of you can determine that that was likely what was used in the installation of the joist hanger hanging or the joist hanger installation hardware. All right, so band joists and beam bearing do not appear to meet minimum support measurements or mounting requirements. Assembly would have to be deconstructed to determine the actual bearing measurements. Site building a two-ply beam requires specific mounting hardware and configuration that does not appear to have occurred. The two-ply site-built beams have intermittent missing mounting fasteners and areas. The beam post mounting hardware is incomplete. The Simpson strong tie installation instructions call for two to be installed per location. Only one is installed on each post currently. So, these guys, I met, I know, I don't know who they are. I looked these guys up that were installing this, and they were just a couple of younger kids that, decided to start a deck building business. And unfortunately, I think they're out of business now. I think probably because of this, inspection. I mean, not because of my inspection, because of their work. But their Facebook page is no longer live. And when I went and looked at their Facebook page, a lot of unfortunately, sorry, Jeff, I didn't. Not unfortunately, they should be out of business. But So anyway, so when I looked at their Facebook page, all their decks were built in this same manner. So unfortunately, I think they're going to have a lot of failures come, on the backside over time as their decks that they installed have aged out. The two-ply system or the two-by, they did not they basically just, I think there's a couple of nails every so often, but that's really all they did to adhere these two this beam together. Same thing over here. And again, I'm showing. So because this one was in Arkansas and we are a licensed state, I was able to use code references in this instance. But like I said, so again, we're just calling out the installation instructions and how things should have been installed, pictures, diagrams. Yeah, thank you. Like I said, Adam, this is I don't do this for home inspections. I only do this for litigation when I go into this kind of detail. But I figured this would be a great everything that we talked about in the class today, I've pretty much done in person on site. So just keep that in mind. These things are out there, even though we are a licensed state and they did have this deck inspected by the AHJ. The AHJ had them. I think they did a stop work on them 3 times, which is why the client ended up calling me. They're like, if the AHJ is doing stop work orders on them, I don't want them to finish doing this crap work, so that's why I was called out. But so again, calling out installation instructions, and this is where they use these wedge anchors and these CMU block walls. So you can see these CMU block walls are not grouted in, and they use wedge anchors. And so I don't know if I included it in the picture, but you can see where they installed these through. The block wall is now damaged along where they installed these anchors. It's cracking, they're damaging, they're falling out, and primarily because this is not the correct application for this ledger in this instance. And specifically in the redhead true bolt says not recommended for use in lightweight masonry such as block or brick. Again, it goes back to them not reading the installation instructions. And so again, we find here, so Jeff, I said unfortunately, because what's funny is that this contractor actually called me first. They called me first and asked me to come out and evaluate their work because they had all these stop work orders. The client was unhappy with their work. But before I could go out there, the homeowner called me separately without knowing that I was already contacted by the contractor. And so he said, when he called me, he's like, they're never coming out here again. I would never allow you on my property if you were working for them. So we went from working for the contractor to try and help them get this all done correctly. And we went to the homeowner, and then the homeowner ended up hiring us, officially hiring us. And then that's why we provided this report. And subsequently, I think, like I said, uh, the contractor is no longer in business. So I said unfortunately because he was trying to eventually do the right thing, but it was too late. Um, so you can see here how they just wallered out all the holes. Even the washers don't cover some of the holes, so that's out, definitely out of scope. Um, missing washers, missing bolts. But again, I think a lot of this they were intending to put them on, but didn't get to that point. They would, stop before we got there. And then talking about the mounting hardware. So this is a great picture where they incorrectly notched the 6x6 support post. They did attach it to the joist, so you can see, they have the joist hanger. They did attach the notched 6x6 to the adjacent joist, but they over notched it. And so because they over notched it, now in order to make it all level and everything square on top of the deck, they installed all these crazy wedges, these site made wedges, which does not comply. Yeah, they should install decks for the House of Florida. That'd be amazing. Um, so if anything looks wonky like this, just do your due diligence. For me personally, I would call out the specifics of how it's not, but in this, you wouldn't even really have to. It's obvious that this is not standard. And then, so the back deck was a new deck, but the side deck they had was a repair. So, or was like a modification. They were trying to upgrade it. But in the process of upgrading, they actually caused damage. So in this instance, the ledger flashing was existing, but as they were installing and tearing things apart, they actually damaged the ledger flashing. So they have a cut through there. And again, so and missing mounting hardware on the deck on the joist hangers. The ledger was existing, so they didn't change any of the mounting bolts. You can see mounting bolts are not standard. They're random. They're not correctly spaced. They're not alternating, all kinds of stuff like that. So um, again, so just protect yourself. So that's why, they asked me to do both decks, but so that's why I wrote this comment. The refurbished side deck appears to be complete. Only items that are clearly modified were evaluated, and because the side deck is partially refurbished, cannot be held to new standard. The following opinions should be considered. So just when you're wording, make sure you're protecting yourself. I hope you recognize a lot of that whenever in the comments, especially on that last report. How I write reports is, uh, you know, I built a multi-inspector firm. I had 7 inspectors, an admin, a salesperson, and with that many inspectors, we were doing 30 inspections a week. And with all of that work, just naturally comes litigation, where people make claims. I was running through probably a claim a quarter. And to do a claim, it takes you about a month from the beginning of them calling you and complaining to finalization, whether insurance takes care of it or you refund their inspection fee or however it ends up going. But it takes about a month to go through a claim. The uh, so when I write my reports, I write them in a manner that 100% protects myself and protects my inspectors, while still providing a lot of very valuable information. So in the inspection standards of practice, it states that if something is in the standards of practice and you can't get to it or you can't inspect it for whatever reason, you need to make sure that it is in the report that you cannot inspect it and why. The same thing goes, and so I take that approach to everything. If I can't get to that, if I can't get to a portion of the attic or I can't get to the crawl space, you state in there, cannot get to 60% of the crawl space, which would include the connections for the ledger fast and the ledger connections, right? Or cannot get to, the east side of the crawl space, or make sure that you are explicitly stating what you could and could not get to, so that way you're protected. So that's why so I write my reports as if a lawyer is going to read it to a judge in court. Not that it happens a lot, but if you write your reports in that fashion, with that in mind, then if you do ever end up, having to defend your report or defend or help your client, you know, with the contractor that did the work or whatever, then you feel confident going into, if you do go to court or you do be or are deposed, sorry, not deposed, which can have, you can be deposed no matter if you give permission or not. If a judge, if they submit your inspection report in the findings for their court case, then and a judge orders you to come to court and talk about your report, you don't have a choice. So that's why I write my reports and just protect yourself, protect the client, and making sure that you wording, the tense of a word can make a lot of difference. So let's see, where are we at on time? Oh, we got 10 minutes. So let's see here, we got a question. Do all deck support posts and guard posts have to be 6x6? Adam, in new code construction, yes, unless if it's attached to the home. If it's not, if it's a standalone or an isolated deck, then there's a lot more leeway in using 4x4 posts. But the minimum should be 6x6. If you use a 4x4, then there are specific requirements that have to be met in order for the use of those 4x4s. But again, a lot of this is newer standard. I mean, I don't. I know it's in the 2021 IRC, but I don't know how far back it goes for the 6x6 requirement. So, again, if you're on an existing deck, and it's using 4x4 posts, the deck is 10, 15 years old, everything is operating as intended, there's no twisting, there's no moving, everything looks good, then I personally don't call out the 4x4 post. I don't want, for me personally, I don't want to create waves that where, the homeowner, if the client, if you put it in there that, hey, this should be a 6x6 post, and then they take that in your report and they tell it to the seller, hey, the inspector said that these have to be 6x6 posts for safety, or whatever language you want to use. But the deck is 15 years old or 10 years old and there's nothing wrong with it, it's not moving, it's not anything, then you're going to have that seller is going to have conflict with the buyer, and the buyer is going to be like, well, the inspector told me so, and the seller is like, it's fine. And then you get that conflict, and you want to try to leave as much of that conflict out as possible, so that you have a smooth transaction. And then on top of that, as long as you're truthful and you could state current standard recommends or requires 6x6 posts. Your house has 4x4 posts, but there does not appear to be, there's no evidence of defect or deterioration. So that's kind of how I would approach that if I wanted to put something like that in my report. Obviously, if there is damage or defect, or you can tell that the posts are twisting or something is leaning or it's not level, that gives you the ammo that you need to be able to call out the need for upgrade or repair or whatever. Let's see. Let me go back through here. How's Adam? So we have 7 minutes. If anybody else has any more questions, I'd be happy to answer them. but I'm gonna try and come through here and see if there's anything else I didn't really hit on that I think would be good to hit on. So I think maybe we didn't really hit on it a lot, but when you have, and I know it's kind of hard to see. Let me see if I can zoom in. Yeah, that looks better. So absolutely, Kevin. Uh, so make sure on your beams when your beams are being supported on a notched support post that you have through bolts. Um, you have through bolts with nuts and washers for the exact same reason that you have to have them on the ledger board. Because over time, water just naturally soaks in and penetrates in through those areas. So make sure that there's those through bolts when you can see both sides there. Let's see, what was the other? I was just thinking about something. Uh, oh, so when you have a band joist on the outside of a deck, and all they've done, let me think about this. So, yeah, so when they face attached the band joist to a support post, a lot of times if you know through bolts and lag bolts are a fairly recent requirement because at least in my area they are. So, and again, we didn't have code implementation until 2000. 1998 was our state electrical code was enforced, and then after that we ended up getting state code for the rest of residential construction. But so you have decks that were built and that are still out there that were built in my area before 2000, and so you have a lot of misapplied construction knowledge where they face attached a lot of these band joists and then they threw up tons and tons of nails and screws or whatever, and so that has started to splinter the ends of those band joists. So definitely want to call that stuff out. And all right, I think, yeah. So we just got 4 minutes. So I'm gonna let AJ take back over. Guys, I appreciate you listening to me, having me on. I love doing this stuff, and appreciate you coming back and seeing me again.